You have looked at the night sky, everyone has. You have seen stars scattered above you and felt, perhaps without thinking about it, that you understood what you were looking at. Stars, constellations your parents pointed out to you when you were small. The pale stripe of the Milky Way on a clear night. You have seen photographs of galaxies in textbooks and documentaries. Elegant spirals of light turning slowly in the dark. You've absorbed a picture of the cosmos that feels familiar and settled and known. Almost none of it is correct, not metaphorically, not in some abstract philosophical sense. Literally, the picture of our galaxy that most people carry in their heads is built on assumptions that have collapsed one by one over the last 10 years. We did not know the shape of our own galaxy. We did not know how many arms it has. We did not know how many stars it contains. We did not know that the most beautiful feature of spiral galaxies, the arms themselves, are not real objects. And until very recently, we did not know that some of the stars you can see on a clear night do not belong here at all. They are immigrants from a dead galaxy that no longer exists. Let us begin. Start with something that should be simple. How many stars are in the Milky Way? This is the kind of question you would expect astronomers to have answered a long time ago. They have not. Current estimates range from 100 billion to 400 billion. That is not a rounding error. That is a factor of 4. Imagine asking how many people live in a city and receiving the answer somewhere between 2 million and 8 million. That is the level of precision we have about the galaxy we live in. The reason is deceptively simple. You cannot count what you cannot see, and we cannot see most of the Milky Way. There is a region that astronomers call the zone of avoidance, a thick band of gas and dust running through the plane of the galaxy that blocks visible light almost completely. Everything behind it is invisible to traditional telescopes. We are sitting in our bedroom trying to map the rest of the house, but the walls are in the way. Now consider the shape. Every picture of a spiral galaxy you have ever seen shows long, graceful arms sweeping outward from a bright center. It is one of the most iconic images in all of science. For decades, astronomers argued about whether our galaxy has 2 of these arms or 4. They went back and forth, 2 arms, 4 arms, 2 arms. Again, it was not until ESA's Gaia Space Telescope mapped the positions of individual stars that the answer became clear. 4 arms. We settled a basic question about the shape of our own home less than 10 years ago. Gaia operated for just over a decade, performing 3 trillion observations of nearly 2 billion stars before it was finally switched off on the 27th of March, 2025. Before Gaia, we were guessing, but here is where the picture starts to break in a way that most people never hear about. Those spiral arms, the ones you see in every galaxy photograph, the ones that define what a spiral galaxy is, they are not structures. They are not solid. They are not collections of stars that orbit together as a group. They are an illusion. The leading explanation is something called density wave theory. Imagine a highway with a slow stretch of traffic. Cars enter the slow zone, bunch up, crawl through it, and then speed away on the other side. The clump of cars is always there, but it is not made of the same cars. Individual vehicles pass through it continuously. The traffic jam is real. The traffic jam is visible, but the traffic jam is not a thing. It is a pattern. Spiral arms work the same way. Stars and gas orbit the galaxy at different speeds. As they pass through certain regions, they slow down and compress. Gas clouds collapse. New stars ignite. The region glows brighter. It looks like an arm. But the stars that are in the arm right now will not be in the arm later. They will move through it and out the other side. The arm stays. The stars do not. The beautiful spirals you see in every photograph of every galaxy are cosmic traffic jams. Persistent patterns in the flow of matter, not objects, not structures. Illusions drawn in light by the movement of billions of independent stars that do not know they are part of a pattern. This means something strange for where we are right now. Our sun sits in what is called the Orion Arm, roughly 26 zeros in light year from the center of the galaxy. But the sun is not permanently in this arm. It entered the arm, it will pass through it. Eventually, it will emerge on the other side into the gap between arms, and the night sky, will look subtly different. The constellations will change, not because the stars moved in any dramatic way, but because the sun drifted out of a traffic jam it was never attached to in the first place. So, The arms are not real structures. The star count is uncertain by a factor of 4. The shape was debated until last decade. But there is one more thing, and this one changes everything. In 2018, a team from the University of Groningen in the Netherlands, led by astronomer Amina Helme, was studying Gaia data on 7 million stars in the neighborhood of the Sun. Among those 7 million, they found 30,000 that were moving wrong. Not slightly wrong, completely wrong. These stars were orbiting the galaxy in the opposite direction to everything else. Every other star in the Milky Way, including the Sun, orbits the galactic center in roughly the same direction, the way cars all drive the same way on a highway. These 30,000 were driving into oncoming traffic. Their chemical composition was different too. They were made of different stuff than the stars around them. They did not form here. They came from somewhere else. When the researchers ran simulations to figure out what could produce this pattern, the answer was violent. Roughly 10 billion years ago, a dwarf galaxy, about the size of the Large Magellanic Cloud, crashed into the Milky Way. The Milky Way at that time was only about 4 times larger than the invader. The collision was not gentle. It tore the smaller galaxy apart completely. Its stars were scattered throughout the Milky Way, where they remain today, still moving on the trajectories they inherited from a galaxy that no longer exists. The researchers named this dead galaxy Gaia Enceladus. Its remains form most of what astronomers call the inner halo of the Milky Way. 13 globular clusters and hundreds of variable stars still follow paths that trace back to Gaia Enceladus. They are fossils, bones of a galaxy buried inside our own. And Gaia Enceladus was not the only one. Further analysis revealed the remains of another collision, a smaller galaxy nicknamed Seoia that hit the Milky Way not long after, then another, then another. According to current estimates, the Milky Way has consumed at least 6 separate galaxies over its history. It is not a peaceful island of stars drifting quietly through the void. It is a predator. It has been eating its neighbors for billions of years, and it has not stopped. Right now, at this moment, the Sagittarius dwarf galaxy is being torn apart by the Milky Way. It has already collided with us 3 times over the past 4 to 5 billion years. Each pass rips more stars away from it. Each pass feeds the Milky Way. Simulations suggest that one of these collisions, roughly 7 billion years ago, compressed gas clouds in the Milky Way's disk and triggered a burst of star formation. One of the stars born in that burst may have been our Sun. If the simulations are correct, then the Sun exists because the Milky Way was in the process of devouring another galaxy. You are sitting on a planet that was born from an act of galactic cannibalism. Now pull back. Think about what you have just heard. The arms of the galaxy are not real structures. They are moving patterns, illusions of compression. We did not know whether our galaxy had 2 arms or 4 until this decade. We cannot count the stars to within a factor of 4 because most of the galaxy is hidden behind dust we cannot see through. 30 Sirian stars near our Sun are moving the wrong way because they are the remains of a dead galaxy that was consumed 10 billion years ago. The Milky Way has eaten at least 6 other galaxies. It is eating one right now, and the Sun itself may owe its existence to one of those meals. This is the galaxy you live in. This is the night sky you thought you understood. In September of 2024, astronomers using ESO's VISTA telescope in Chile published the most detailed infrared map of the Milky Way ever created. 13 years of observations, 200,000 images, 500 terab of data, more than 1.5 billion objects cataloged, 10 times more than any previous survey. VISTA's infrared camera can see through the dust and gas that blocks visible light, peering into the regions of the galaxy that have been hidden from every optical telescope ever built. The project leader, astrophysicist Dante Maniti, said something that should make you pause. We made so many discoveries, we have changed the view of our galaxy forever. Forever about a galaxy we thought we already understood. Among those discoveries were stellar nurseries that no one knew existed, new globular clusters buried behind dust for billions of years, young stars in regions of the galaxy that were believed to contain only ancient stars, and structures faint, vast, stretching across the galactic bulge that had never appeared on any previous map. 80% of what the Milky Way contains was invisible to us until infrared technology matured enough to see through the dust. 80%. You have been looking at 20% of the galaxy and calling it the whole picture. The sky you see is not the sky that exists. It is a fraction, a sliver, a keyhole view of something vast and largely unknown. Before we go further, if you are kind enough, a gentle like and tap on subscribe would mean the world to me. It is a small gesture, but I hold it with deep gratitude because every bit of your support keeps this tiny universe alive. There is a question that most people never think to ask about galaxies. Can they die? The answer is yes. They die slowly, they die visibly, and the process has already begun in ours. To understand what a dying galaxy looks like, start with what a living one looks like. A living spiral galaxy is full of gas and dust. These are the raw materials for making stars. When gas clouds collapse under their own gravity, they fragment and ignite into new stars. Some of those stars are massive and blue and searingly hot, burning through their fuel in just a few million years before exploding as supernovae. Those explosions scatter heavy elements back into the surrounding gas, enriching the next generation. It is a cycle. Gas becomes stars. Stars become gas. New stars form from the enriched remains of old ones. As long as the gas supply holds, the galaxy keeps producing new stars, and the spiral arms remain bright and defined. A living galaxy glows with color, blue from young hot stars, pink and red from hydrogen nebula where new stars are being born. It looks busy, it looks active, it looks alive. Now watch what happens when the gas runs out. Without gas, no new stars can form. The massive blue stars, which burn fastest, die first. Within a few 100 million years, the blue disappears entirely. What remains are the smaller, cooler, longer-lived stars, red and orange and white. The galaxy's color shifts from vibrant blue-white to a pale, washed-out glow. The spiral arms, which were defined by ongoing star formation within density waves, begin to lose their shape. Without fresh young stars lighting them up, the arms fade. The structure softens. What was once a crisp spiral becomes something ghostly. A galaxy with the memory of arms, but not the substance. Astronomers call this stage a lenticular galaxy. It still has a disk shape, it still rotates, but the arms are gone, the color is gone, the star formation is gone. It is a galaxy running on what it is left, and what it has left is slowly burning down. The final stage is an elliptical galaxy. No disk, no arms, no dust lanes, no nebulae, no star formation at all. Just a smooth, featureless cloud of old stars orbiting in random directions. In an elliptical galaxy like Messier 105, only one sun-like star is born roughly every 10,000 years. Compare that to the Milky Way, which produces several new stars every year. An elliptical galaxy is not empty. It still contains billions of stars, but it is finished. It will never make anything new. It will simply sit there dimming as its remaining stars burn out one by one over trillions of years. No dramatic explosion, no sudden collapse, just a slow, quiet fade into darkness. That is how galaxies die, not with a scream, with a whisper. The part that most people do not realize is that this is not a theoretical sequence. We can see it happening. Astronomers have observed galaxies at every stage of this process. Starburst galaxies burning through their gas at extraordinary rates. Anemic spirals where star formation has slowed to almost nothing. Lenticular galaxies caught in the transition, their arms half dissolved, their colors draining. Elliptical galaxies sitting silent at the end of the road. The entire life cycle of a galaxy from birth to death is spread out across the observable universe like frames of a film laid end to end. And the Milky Way is somewhere in that film. Not at the beginning, not at the end, somewhere in the middle, still producing stars, still alive, but not forever. Now, here is where the story folds back on itself. Remember what you heard in the first chapter? The Milky Way has eaten at least 6 galaxies. It is currently devouring the Sagittarius dwarf. And it turns out that these collisions are not just how galaxies grow. They are also how galaxies accelerate their own death. When two galaxies collide, the gravitational chaos compresses gas clouds throughout both galaxies simultaneously. This triggers enormous bursts of star formation, far more intense than normal. The galaxy blazes with new stars. It looks more alive than ever. But this is deceptive. The starburst consumes gas at a rate that cannot be sustained. What would have lasted billions of years at a normal rate gets burned through in a few 100 million. The collision that makes a galaxy look most alive is the same event that pushes it toward death. It is spending its inheritance in a single night. The Milky Way has been through this process multiple times. Each merger triggered a burst. Each burst consumed gas that will never be replaced. And there is one more collision coming, the biggest one. The Andromeda Galaxy is moving toward us at roughly 110 kilometers seconds. It is currently 212 million light-years away. In approximately 4 to 5 billion years, it will collide with the Milky Way. The two largest galaxies in the local group will merge into a single enormous galaxy that astronomers have already named Milkdromeda. The collision will trigger the most intense starburst our galaxy has ever experienced. The night sky, if anyone is still here to see it, will be unrecognizable. New stars will ignite across the entire merged disk. Nebula will flare in every direction. For a brief window measured in hundreds of millions of years, Milkdromeda will be one of the most spectacular objects in the local universe. And then the gas will be gone. The starburst will have consumed the last reserves of both galaxies. Star formation will stop, the arms will dissolve, the colors will drain, and what remains will be an elliptical galaxy, smooth, featureless, slowly dimming over trillions of years. The Milky Way, as you know it, will no longer exist, not because it was destroyed, because it grew up, because it merged, because it burned through everything it had. The galaxy that contains every star you have ever seen, every planet anyone has ever discovered, every world where life might exist, will become a quiet cloud of aging stars with nothing left to build. But the VISTA survey discovered something inside this story that nobody expected, something that does not fit. The center of the Milky Way, the galactic bulge, was long believed to be one of the oldest parts of the galaxy. The assumption was that the bulge formed early, filled with ancient stars, and then sat there unchanged for billions of years, while the rest of the galaxy evolved around it. The stars in the bulge were supposed to be old, 8 billion years old, 10 billion years old, relics from the beginning. VISTA found young stars where no young stars should be. A team led by astrophysicist Dante Miniti identified 35 classical Cepheid variables in the galactic bulge that were less than 100 million years old. Some were as young as 25 million years. In a region that was supposed to contain exclusively ancient stars, VISTA found stars that are younger than some dinosaur fossils on Earth. The team mapped these young Cepheids and discovered they trace a thin disk of recent star formation stretching right across the galactic bulge, hidden behind thick clouds of dust that had concealed it from every previous survey. This means star formation in the Milky Way center has been ongoing for at least the last 100 million years. The bulge is not a dead relic, it is still active. The heart of the galaxy is still beating. And we did not know this until an infrared telescope looked through the dust that had been hiding it. But VISTA also found something ancient. In 2016, a team discovered 12 RL-Ray stars at the very center of the Milky Way. RL stars are old, very old. They are typically found in globular clusters, dense groups of ancient stars that orbit in the outer halo of the galaxy. Finding them at the center was unexpected. Their presence suggests that the core of the Milky Way was built, at least in part, by the merging of primordial globular clusters that fell inward during the galaxy's earliest days. The galactic bulge did not form as one single structure. It was assembled piece by piece, cluster by cluster, collision by collision. So the center of the Milky Way is both younger and older than we thought. Young stars that should not be there, and ancient stars that came from somewhere else. Both discoveries invisible until we looked in infrared, both hidden behind the same dust. The Milky Way is not what you were taught. It is not a stable structure that has looked roughly the same for billions of years. It is a composite assembled from the remains of at least 6 dead galaxies, still actively consuming a 7th, carrying 30,000 foreign stars in its own neighborhood that orbit the wrong way, producing new stars in its ancient heart where none were expected, and heading toward a collision that will eventually end it. Every galaxy you have ever seen in a photograph is somewhere on this same path. Some are young and burning bright, some are fading, some are already dead. And the Milky Way, the one galaxy you can step outside and see with your own eyes on a clear night, is no exception. It was born from collisions. It grew through cannibalism, And one day it will go quiet. The graveyard does not announce itself, it just gets darker. 105 years ago, astronomers did not know that other galaxies existed. This is not an exaggeration. In 1920, the scientific consensus was that the Milky Way was the entire universe. Everything visible in every telescope was assumed to be inside a single system of stars. The fuzzy spiral shapes that some telescopes could resolve were classified as nebula, clouds of gas within our galaxy, nothing more. On April 26, 1920, two of America's most prominent astronomers stood on a stage at the Smithsonian Museum of Natural History in Washington and debated the question. Harlow Shapley argued that the Milky Way was everything. The spiral nebula was small nearby gas clouds. The universe was one galaxy, and that galaxy was us. He Curtis argued the opposite. The spiral nebula were other galaxies, other island universes, vast and distant and independent. The debate ended without resolution. Neither side had the data to win. 3 years later, in 1923, Edwin Hubble pointed the 100 Hooker telescope on Mount Wilson at the Andromeda Nebula. He found a Cepheid variable star inside it. Cepheids are cosmic yardsticks. Their pulsation period tells you their true brightness. Compare that to how bright they appear from Earth, and you get the distance. Hubble measured the distance to Andromeda. It was 900,000 light-years away, far outside the Milky Way. The number was later revised upward to 212 million light-year. But the conclusion was the same. Andromeda was not a cloud inside our galaxy. It was another galaxy entirely. In a single observation, the size of the known universe expanded by a factor that is difficult to put into words. The Milky Way went from being everything to being one structure among what we now know to be at least 2 trillion galaxies in the observable universe. That was 103 years ago. In astronomical terms, we learned that our house has neighbors yesterday, and we are still finding rooms in our own house that we did not know existed. In 2011, Vista discovered 2 new globular clusters hidden behind the dust of the galactic center. Before that discovery, only 158 globular clusters were known in the entire Milky Way. These objects are rare. Each one is a tightly packed sphere of tens of thousands to millions of ancient stars bound together by gravity orbiting the galactic core. They are among the oldest structures in the galaxy, some more than 10 billion years old, and 2 of them had been sitting behind a curtain of dust that no visible light telescope could penetrate. One of them, designated VVCL00002, may be the closest known globular cluster to the center of the Milky Way. It had been there for billions of years. We simply could not see it. But there is something stranger. Scientists have wondered whether VVCL00001 and the previously known cluster UKS1, which sits nearby, are gravitationally bound to each other. If they are, they would be the first known binary globular cluster pair in the Milky Way. Binary globular clusters have been observed in other galaxies in Centaurus A and the Large Magellanic Cloud. Some astronomers believe that when binary clusters eventually collide and merge, they produce the most massive globular clusters known, like Omega Centauri, a cluster so large that some suspect it is actually the stripped core of a galaxy the Milky Way devoured long ago. If VVCL0001 and UKS1 are truly a binary pair, we may be watching the early stages of a process that builds the largest stellar structures in existence, and we found it hiding behind dust in our own backyard. Vista also found 96 new open clusters, younger and looser groups of stars scattered across the galactic plane. Some of these were on the far side of the galaxy in regions so obscured by dust that no previous survey had ever detected anything there. One of them, VVVVC00003, was found 15,000 light-years beyond the galactic center, the first open cluster ever discovered on the far side of the Milky Way. It had been there the entire time, visible to anyone with the right instrument, invisible to everyone who did not have one. This is the pattern that should unsettle you. Not that we got things wrong in the distant past. Not that Shapley was mistaken in 1920, but that we are still finding fundamental things we missed right now in the galaxy we have been studying longer than any other. Vista's survey covered roughly 80% of the Milky Way's luminous mass, but it was one telescope operating in one part of the infrared spectrum from one location on Earth. The data it produced, 500 terab, has already led to more than 300 scientific papers, and scientists believe they have only begun to explore what is in it. Meanwhile, Gaia's story is also not finished. The telescope was switched off in March of 2025, but 2 more data releases remain. Data release 4, expected in 2026, will cover the first 5 and 1/2 years of Gaia's mission at an extraordinary level of detail. It will include precise measurements of stellar wobbles that could reveal the locations of exoplanets and will create the largest catalog of binary star systems ever compiled. Data release 5, tentatively set for the end of the decade, will include everything, all 10 and 1 to 2 years, all 3 trillion observations, every star measured at the highest possible precision. Scientists describe it as a treasure trove. They also acknowledge they do not fully know what is inside it, and there is already a successor being planned. Gaia In-Air, a next-generation telescope similar to Gaia, but equipped to see much deeper into the infrared, is being designed to launch in 2045. It will be able to peer through the dust that blinded Gaia's visible light sensors. And because it will observe the same stars that Gaia mapped 2 decades earlier, the time gap between the 2 missions will provide an even larger baseline for measuring parallax, the tiny shifts in a star's apparent position that reveal its true distance. 20 years of additional motion, 20 years of additional data applied to billions of stars that have been drifting through the galaxy the entire time. Think about what this means. In 1920, we did not know that other galaxies existed. In 2018, we discovered that our own galaxy is a composite built from the consumed remains of at least 6 others. In 2024, we published the first infrared map comprehensive enough to reveal 80% of the Milky Way's content and found structures that had been hidden for billions of years. And the data that will arrive over the next 2 decades will almost certainly reveal things we cannot currently predict, because every previous generation of instruments has done exactly that. We have been studying the Milky Way for as long as we have had telescopes, 4 centuries. And in those 4 centuries, we have been wrong about its size, wrong about its shape, wrong about the number of its arms, wrong about the age of its center, wrong about whether it was the only galaxy in existence, and wrong about whether it assembled peacefully or through violence. We corrected some of these errors decades ago. We corrected others last year, and some of the things we currently believe to be true will almost certainly be corrected by instruments that have not been built yet. At the beginning of this video, I said that the sky you see is not the sky that exists. That was not a hook. It was the most honest statement I could make about our position. We live inside a galaxy that we cannot fully see, built from galaxies that no longer exist, structured by forces we cannot directly observe, filled with objects that remained hidden until we learned to look in wavelengths our eyes were never designed to detect. And the most unsettling part is not what we have gotten wrong. It is how recently we got it right and how much of the galaxy remains in a darkness that no telescope has yet been pointed at. In the first chapter, I compared our situation to sitting in a bedroom trying to understand the layout of a house we cannot see. That analogy was incomplete. We are sitting in a bedroom. We have just learned that the house is far larger than we thought. We have just discovered that it was built from the ruins of at least 6 other houses that were torn down before ours was finished. We have just found rooms behind walls we did not know were there. And somewhere in this house, behind doors we have not opened, in rooms we have not entered, there are things we have not found yet. We do not know how many rooms there are. We do not know what is inside them. We only know that every time we open a new door, what we find changes everything we thought we knew about the house we have been living in our entire lives. The doors are still there. Most of them are still closed.